Hello everyone. This video is about the various different types of message-oriented communications in distributed environment. Message-oriented communication types. Message-oriented communication can be viewed along two axes. One, persistence, that is, whether the system is persistent or transient. Second, synchronicity, that is, whether it is synchronous or asynchronous. Now, persistent and transient communication. Persistence. In persistent communication, messages are stored at each intermediate hop along the way until the next node is ready to take delivery of the message. It is also called a store and forward based delivery paradigm. Example, postal system, email, etc. In transient communication, the messages are buffered only for small periods of time as long as sending or receiving applications are executed. If the message cannot be delivered or the next host is down, it is discarded. Example, general TCP/IP communication. Synchronous communication. Synchronicity. In synchronous communication, the sender blocks further operations until some sort of an acknowledgement or response is received. Hence the name blocking communication. In asynchronous or non-blocking communication, the sender continues execution without waiting for any acknowledgement or response. This form needs a local buffer at the sender to deal with it at a later stage. Now, different combinations of communications are available. The first combination is persistence and synchronicity, that is persistent asynchronous. Now here A is the sender and B is the receiver. It is shown in the diagram. Dark line depicts execution. A sends a message and keeps executing without blocking. The message sent from A will take an arbitrary amount of time to reach B. A may or may not be running by the time the message reaches B. Disk or multiple memory queues could be used for storage at B's side. There is a guarantee that the message will eventually reach B. B receives this request and processes it then. Example, emails can take an arbitrary amount of time to reach, and when the receiver reads the email, the sender might not even be running. Next combination is persistent synchronous. It is shown in the diagram. Here, A sends a message and is then blocked. It is shown by the dotted line. The acknowledgement is for receipt, not for delivery or for the response. Because this model is persistent, the message may stay in B's queue or in any router along the way for an arbitrary amount of time. Example, messaging and chat applications. Many messaging systems are persistent and can tell us the delivery status. Next type is transient asynchronous. Here, A sends the message and continues execution. That is, it will be non-blocking. B has to be running because if it is not running, the message will be discarded. Even if any router along the way is down, the message will be discarded. UDP communication is an example of transient asynchronous communication. The function MPI buffer send is an implementation of this. It is shown in this diagram. Next will be receipt-based transient synchronous communication. A's message to B is blocking, that is synchronous, until an acknowledgement is received. This acknowledgement simply tells us that the message was received at the other end. It does not tell us anything about the process has started. Delivery-based transient synchronous communication. This is an extension of recipient-based transient synchronous communication. As shown in the figure E, A will resume running when B takes the delivery of the message. The acknowledgement comes a little bit later than the previous method. This is essentially asynchronous RPC because from the perspective of an RPC, we are not blocking for the reply. Response-based transient synchronous. A resumes execution upon receiving a response. That is, not only has the message been delivered, but it has been processed and the acknowledgement comes back in the form of a reply. This is traditional RPC. The client is blocked for the entire duration. The reply comes back. Message-oriented transient communication. Berkeley socket primitives and message passing interface are examples of message-oriented transient communication. These systems do not use on-disk queues for message storing. MPA buffer send simply appends the outgoing message to the local send buffer and then keeps running. Thus, it is transient asynchronous communication. MPA send sends a message and waits until copied to the remote buffer. This is similar to delivery-based transient synchronous communication. MPI synchronous send waits until receive start and MPI send receive waits for a reply, classifying each to receipt based and reply based transient synchronous communication respectively. Next will be message-oriented persistent communication. This class of communication is called message queuing systems, MQS. They use on-disk buffers to ensure persistence of messages over long periods of time. Common open source examples include Kafka, RabbitMQ, ActiveMQ and ZeroMQ, etc. An application level example for this is emails. All emails are stored on disk till delivery. The queues have names or addresses which are used to explicitly put messages into the queue. This is a form of store and forward communication. Persistence neither guarantees the duration in which the message will be delivered nor the reading of the message. It only ensures delivery. Thus, it is a loosely coupled communication. So these are the different types of communications possible in distributed environment, and references used for this content are shown in the slide. Thank you.